Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have started a new unit on algebra. And I talked to the kids about what algebra actually is. And algebra is just the representation of real life situations using math language. That's all it is. It's taking real life, finding the patterns in real life, and representing that with math language. So what we did is we started off with a pattern where a farmer was going to build a fence using wooden rails. And in the first pattern, there was one section of fencing. In the second pattern, the first pattern, there was one section of fencing with a total of 5 rails. 1, 2, 3, 4, 5. So there was 5 rails. And in the second pattern, the second section, there was 1, 2, 3, 4, 5, 6, 7, 8, 9 rails. And in the third section, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rails. And what the kids did first is they drew out the next 2 sections of fencing. So in the next section of fencing, you'd have the first section that you initially built, like so. And then the second section would have another one added on. And then the third was like that. And then to make the fourth section, you have to do another set of 4, right? So there would be 17 rails used in that section. And then I had them build the fifth section. I got to try to draw this one better. So there was the first, then another 4, then another 4, then another 4, and then another 4. And there would have been 21 rails in that section. So that's what we did first. We just continued a pattern of fencing. And what they noticed right away was that every time, the number of rails always added on 4. We were always adding on 4 rails to get the next set of rails. That was our first thing we did. Then we took that picture pattern and we represented it in a chart. So we actually started our chart with 0 sections, 1 section, 2 sections, 3 sections, 4 sections, 5 sections, and 6 sections. Now what I meant by 0 sections was you initially started with that one post, this one post right here. So when there were 0 sections, there was actually one post. Then when you completed one section, there was a total of 5 posts. And then when you completed 2 sections, there was a total of 9 posts. And so on. Then 13, then 17, then 21. We didn't draw this one, but we saw that the pattern was increasing by 4 every time. So the next one would be 25. And we noticed here that the pattern was increasing by 4 every time. To go from one section to the next, we were always adding on 4 rails. But we also looked at another pattern. So the other pattern was the connection between the sections and the rails. So if you look at this, if we go back to section 1, if we start with our initial post, there was 1, and then we also had our 4 rails that we added onto that to make 5. And then in our second section, we had our 1 post we started out with, and then we had 2 groups of 4 that we added on. In our third section, we had that 1 post we started out with, and then we had 3 groups of 4 that we added on. So really what we were doing here, there's a pattern here. There's always, take the number of sections that you're talking about and times it by 4, and then add on that 1 post that you started with. 1 times 4 is 4 plus 1 is 5. In section 2, you would do 2 times 4 plus the 1 you started out with is 9. In section 3, you would do 3 times 4 plus the 1 you started out with is 13, and so on. So we discovered this pattern in our chart. We could say sections times 4 plus 1 will always equal the rails. 1 times 4 is 4, plus 1 equals 5 rails. 2 times 4 is 8, plus 1 equals 9 rails. 3 times 4 is 12, plus 1 equals 13 rails. 4 times 4 is 16, plus 1 is 17 rails. 5 times 4 is 20, plus 1 is 21 rails. And 6 times 4 is 24, plus 1 is 25 rails. That's our algebraic pattern. That tells us what we do to the sections to get the rails. Now you'll notice in this chart, we've called sections X and rails Y. We're going to start to use those letters for our algebra language. Okay, those letters are called variables. So we're going to use this for our algebra language. We're going to take this algebra pattern that we've discovered, and we're going to write this in the proper algebra form. The first thing we're going to do is write this as the algebraic expression. So the way we do this, the algebraic expression, is we want to say sections times 4. Now I've said sections will be represented by the letter X, and that X could represent any number of sections. It could represent 1 section, 2 sections, 3 sections, 4 sections, 5 sections, 6 sections. So sections is going to be X, and we want to show X times 4. Now the way we write that, we don't write X times 4 because it could get confusing. Does this X mean sections or does it mean multiply? It could get confusing. So the way we show this is we say, okay, sections is going to be represented by X, and the way we show 4 multiplied by X is we just put a 4 in front of it. And we call that 4x. Now the rest of this expression is to add on the plus 1. So we add on plus 1. And that's our algebraic expression. Okay? The X represents the sections. So this part right here means 4 times the sections. Okay? That's the algebraic expression. That's the mathematical language used to represent that pattern. Now the next thing we do is the algebraic equation is just adding on the other part of the table. Now we said rails equals 5. So if you take the sections times by 4, add 1, you'll always get the rails. And we said the rails is equal to y. So x times 4 plus 1 equals y. So we'll write the algebraic equation like this. 4x plus 1, just like the expression, but we'll add on the equals y part. Now, x means rails. And y equals, pardon me, I got that mixed up. The x is the sections. Right? X is sections, and y is rails. And we could also reverse this, and we could say, you know what, we'll start with the rails. Number of rails equals 4 times the number of sections plus 1. Okay? So there's our algebraic equation. Now what we do next is we're going to use this equation to figure out fence posts if we have 30 sections of fence. So we're going to take this algebraic equation that we just discovered, y equals 4x plus 1, and we're going to use it to figure out an exact number of fencing. Let's say the farmer needs to do 30 sections of fencing. Well, we've already said that sections is x. So in this case, we've been given a value for x. We want to know 30 sections of fencing, or we want to know how many posts or rails we'll need when x is equal to 30. To figure this out, we're going to replace the x with 30. So we'll do this. We'll write y equals 4 times 30. X is going to be 30. But we're not going to use a multiplication symbol to show times. We're going to show parentheses to show times because our x is the sections. So when we want to show 4 times the number of sections, we're going to replace the x with 30, and these parentheses or brackets will mean multiply. So 4 times 30 plus 1. Now in order of operations, when we have multiplying and adding in the same question, we do the multiplying first. 4 times 30 is 120 plus 1. And y equals 121 rails. That's how many rails there will be in 30 sections of fencing. Okay, next thing. We're going to make a graph. We're going to make ordered pairs and we're going to graph this. Ordered pairs are x and y values. Each of these x and y values represents a point on the graph. Where do we get these x and y values? Well, we scooch back to our table. We have x and y values right here. When x is 0, y is 1. When x is 1, y is 5. When x is 2, y is 9, and so on. So let's write these as ordered pairs. So you put a parentheses, you put the x value first and the y value second. So when x is 0, y is 1. When x is 1, y is 5. When x is 2, y is 9. When x is 3, y is 13. When x is 4, y is 17. Where did I get these x and y values from? Again, I got them from the chart we made. Okay? These are the x values. These are the y values. And all of these values that I just made into what are called ordered pairs, each of these represents a point on the graph. To make it really simple, each of these represents a point on a graph. And what we're going to do in the next video is we're actually going to graph these points. So in our next video, we'll actually take these ordered pairs and put them on a graph. That's all for now. Flexing Teacher Weber out.